Welcome to another video. Today we will look into few definitions which we commonly use in control engineering. The first one is a block diagram. The block diagram is a diagram that indicates the flow of information around the control system and the function of each part of the system. So block diagram, we will see different block diagrams, open loop for an open loop system, for a closed loop system. So those diagrams help us to understand the flow of information around the control system. Now, closed loop. In a closed loop, the measured value of the controlled variable is fed back to the controller. So that closes the loop. So in forward loop, we will have only the controller and the process controlling the process, and we will take the output. The output information is not fed back in an open loop system, but in a closed loop system, we will feed back the output of the system to the input to compare with the set point and then take corresponding control action on the process, the controlled variable. Controlled variable, the process variable that we want to maintain at a particular value. That is the controlled variable. Say, for example, in a room temperature control system, the temperature of the room is the controlled variable, the variable that we need to keep in the desired value. Similarly, the level of the tank is a controlled variable. So we will control the level of the tank by either controlling the inflow or controlling the outflow. But ultimately, the variable that we need to, the process variable that we want to maintain at a particular value is the level of the tank. So that is the controlled variable in that process. Controller, a device that outputs a signal to the process based on the magnitude of the error signal. So a proportional controller outputs a signal proportional to the error. So the controller is a device that gives the output based on the error signal. So the controller is what instructs or gives out the information to maintain the controlled variable. So in a room temperature control system, the temperature is sensed by some sensor and given to the controller, and the controller decides what action to be taken. So either to turn on a heater to raise the temperature or to turn on a cooler to bring down the temperature to the desired value. And disturbance rejection. One goal of the control system is to enable the system to reject the effect of disturbance changes and maintain the controlled variable at the set point. So there is always disturbance in a process. Say, for example, in a room temperature control system, the opening and closing of a window or opening and closing of the door will change the temperature of the system. So the temperature, which is a controlled variable, is getting affected by the external factors disturbance on which the user doesn't have any control, the opening and closing of window. So the user doesn't have control on this. The controller should give instruction even to reject the effect of disturbance on the system. So that is a disturbance rejection. So we cannot allow the disturbance to affect the system. Disturbances. Any process variables that cause the control variable to change. In general, disturbances are variables that we have no control over. Error. The difference between the value of the set point and the measured variable. So you will have a set point and you will have the present measurement. So that difference is called error. Manipulated variable. Process variable that is adjusted to bring the controlled variable back to the set point. So manipulated variable is a variable that is a process variable that is being adjusted, that is being changed. See, in the previous example of a room temperature control, we are turning on either a heater or a cooler. So that is the manipulated variable. So that manipulated variable helps us adjust the controlled variable, which is the temperature of the room, back to the set point. Negative feedback. Negative feedback, the error is the difference. In negative feedback, the error is the difference between the set point and the measured value. Offset. The steady state value of the error, that is an offset. So ultimately, after using a controller to control the controlled variable, we will still have some offset in case of proportional. We'll see that later. In case of a proportional controller and in case of proportional derivative controller, we will have this offset. So that is a steady state value of the error. There's a difference between the error and the set point. Open loop. Open loop, the measured value of the controlled variable is not fed back to the controller. Positive feedback. In positive feedback, the measured temperature is added to the set point. Now, normally we won't use positive feedback, but there are cases where positive feedback can be beneficial. Set point. Set point, the desired value of the controlled variable, that is the set point. Say, for example, in a room temperature control system, we have a set point of our desired set point of 25 degrees Celsius. And then we measure the present temperature, say it is 20 degrees Celsius. And the controller will give instruction to the heater to turn on the heater, which is a manipulated variable, and the heater raises the temperature from 20 to 25 degrees Celsius, which is our set point. 25 degrees Celsius is our set point. Set point tracking. One goal of a control system is to force the system to follow or track the requested set point changes. Set point tracking is nothing but, suppose we need to maintain a temperature of 25 degrees Celsius, and we reached that set point, and later on the user decides it is too hot and he has to reduce the temperature. He changes the set point to 20 degrees Celsius. Now the controller will give instructions so that the room temperature is tracked or follows that 20 degrees Celsius. Similarly, this tracking happens whenever the user changes the set point. This new set point is being tracked by the controller. So thank you.